Hi folks, hopefully you are joining me on this video. In case you weren't at our live session this morning, my internet was giving me nothing but grief at the school, so I decided let's just make a video of the things I wanted to talk about in the online session, and hopefully it solves some of the problems people are having or answers some of the questions. The first thing is that for some reason I had my quizzes hidden from you, so you didn't get your quiz feedback in a particularly timely manner, even though I had them marked in a timely manner. So I told everybody that I'm going to extend the exam date until Monday, so you can hand it in all the way up till Monday. That gives you 2 extra days plus the weekend, so that should be plenty of time. But we do need to move on to 7.1, 7.2 tomorrow to keep to our schedule and make sure we finish all the stuff that we need to do in grade 9 math. And then on Monday, we've got our next CCA 9 unit, which is going to be an introduction to digital photography. So I'll go through these, and as always, if there's any questions about anything that I'm doing on this little sort of last-minute review for the exam, you just send me an email, and I'll get back to you. So one of the things I noticed on the quiz, although it was generally done very well, is some people just a little confusion over when to flip signs. So number 1, when to flip signs. Okay, now there's only really 3 places where you would ever flip signs. Okay, the first one, and the most important one, is whenever you divide or multiply both sides by a negative number. So here's some examples that would pertain to that. Let's say that we've got something like negative 5x is greater than or equal to 10. Okay? In order to isolate, well, the variable and the coefficient are isolated, meaning they're alone on this side, but it's just that last step where we have to get the x positive and by itself. Well, in order to undo this multiplication, we've got to divide by negative 5. Now, because we're dividing by a negative on both sides to get our final x value, that is where you have to flip the sign. So that cancels and leaves x, and this on this side, 10 divided by negative 5 would equal negative 2. So there's an example of a sign flip. All right, here's an example. Here's an example of no sign flip. What if we had something to the effect of 4x is less than or equal to negative 8? Okay. Now there is a negative number over here, but we don't really need to consider it when we're trying to figure out what x is, right? All we have to do over here is divide by a positive 4. So even though we're dividing, there's a negative number over here, we're not dividing by the negative number. So that's the important part. So this sign does not change, and we're left with x is less than or equal to negative 2. Okay, so no flip on this one. Right? Remember, it's only if you're dividing or multiplying by a negative number. So there's an example of a flip and a non-flip. And now let's do the multiplication part. So if we have something like 1/2 x, let's make it negative 1/2 x, equals 2, not equals, is less than or equal to 2. Okay. We've got this, well, we've got a fraction over here, which is division, which means we know we have to multiply to get rid of that. And what do we have to multiply by? We have to multiply by a negative 2. And whatever we do to one side, we also have to do to the other side. So because we're multiplying by a negative 2, we know we're going to have to flip the sign. So you should probably do it right away. And how does this end up? We've basically got negative 2 times a negative 1, okay, which is just going to equal positive 2. Okay, really what we're doing is we're just canceling out this with this, and we also canceled out the negative sign because we had one there. And all we were left with is 1x, and 1x is just x. So we've got x is greater than or equal to, and then don't forget the negative over here, we've got 2 times negative 2. So this is another example where we've got a sign flip. Okay, this was a sign flip because of division, and this was a sign flip because of multiplication. And then the counter example of that would be very similar. What if we had 1 over 3x is less than 2? Okay, so the counter, or negative 2 rather. So the counter example of this, where we don't have to flip, is if we look over here, our coefficient is 1 over 3. So we don't have to multiply by a negative number, we've got to multiply by a positive number. So to get rid of that fraction, we've got to multiply both of these sides by a positive 3. So the positive 3 cancels with that one in the denominator, leaving us with 1x, which we know is just x. And the sign does not change. So it's negative 2 times 3 is negative 6. So no sign flip on this one. Okay, so the negative number only matters if it's on the, the variable side, the x side or y side or a side or whatever of the inequality. So that should take care of the multiplication and division part. And then there's one more where you might want to flip. Some people do, some people don't. If you have something to the effect of x is greater than or equal to 3, okay, that is not the same thing. Okay, that is not the same thing as 3 is greater than or equal to x. Okay, that is not the same thing. So what this means is if you want to take this and bring the x to the other side, which I often like to do because it makes it easier for me to read in plain English what I'm trying to figure out on my number line, you have to flip that sign. So this would be x is less than or equal to 3. Okay? So just make sure that you understand that it's not like x equals 5 and 5 equals x. Okay? There's nothing to flip. It's just equal. We only have one answer, right? But when we're doing inequalities, it means that there's more than one answer. In this case, the answer, the solution, is anything that's 3 or less than 3. So that's why it's really important that we flip the signs if we need to flip the x to the other side. Okay? Now, this does not apply if you've got something like this. What if we've got here's the flip. And there's nothing to flip over here, so I won't even write that. So what if we've got something like, we've got x, okay, is, x minus 2 is greater than or equal to negative x, okay, plus 2. Okay, now in this case, we're bringing the x to the other side, but don't forget, okay, we're not multiplying or dividing it, because to bring this x to the other side, we're actually just adding, right? We're adding an x here to cancel it, and then whatever we do, to one side, we have to do the other. So when we're doing this particular step, that cancels, and now we've got 2x, and then we got to bring the negative 2 to the other side by adding 2. Okay, and then that cancels with this, and we're left with 2x is less than or equal to 4. There's no flip, okay, because we did addition at this point here when we brought the x to the other side. So don't flip when you're adding or subtracting. The basic idea is you don't have to flip until like the very last step. So if we have something like, let's see, negative 2 times x plus 1 on one side, and we'll say that's less than or equal to negative 3 times x minus 2. Okay, now we do need to do multiplication, but it's only on this side. And over here we have to do multiplication, but it's only on this side. So we're not multiplying by a negative on both sides, or by the same negative both sides, right? So no flip on these ones. Okay, you've got to use BEDMAS, and you've got to solve these first. So this is the distribution, negative 2x, and then negative 2 times 1 is a negative 2. Leave the sign. And then negative 3 times x is negative 3x. And then negative 3 times negative 2 is a positive 6. So we're down to this step, and now we want to bring all the x's over to this side, so I have to add 3x. So if I add 3x to both sides, I'm left with x over here. Minus 2 is greater than or equal to 6. Then I got to get the 2 to the other side, so I got to add 2 to both sides. That cancels this, and I'm left with x is greater than or equal to 8. Now you notice when we got down to the important step down here, our variable is positive, okay, and it's alone. There's no coefficient. And we never had to flip the sign because we never had to divide or multiply this variable and coefficient at the end of the equation. So there is no flip on this one. Okay? You don't really need to decide when to flip until you get down to this last step. And if the last step, if we ended up with something like, let's just say we ended up with, this is a different question, but let's say we ended up with 2x is less than or equal to 8 at the very last step, or the second last step, we're dividing by 2, right? So we end up with x is less than or equal to 4. Once again, there was no flip. So it's just at this point, in the solving process where you decide to flip or not. So don't be flipping early, okay? Don't flip early is the message there. Okay, so that takes care of flipping signs. The next is I wanted to discuss the circle and the dot in inequalities. So when we do the circle and dot, remember they mean opposite things. This would be something to the effect of greater than. Say x is greater than 5. This would be x is greater than or equal to 5. So it's important. Some people had these flipped around, not too many, but some people had these flipped around. Okay? So for instance, let's just do another example. If y is less than 3, our number line would look something like this. Okay, here's 0, here's, whatever, 1, 2, 3. Usually I got a little too close to the end. Okay, so let's say that this is 3. And if y is less than 3, we would have to circle this. I'll do it in red. You have to circle this, but not fill it in. And because it's less than, we have to go this way. And be careful because you need to put the arrow in, or arrowhead. Okay, very important to do that because it represents every number that is less than 3. So that basically goes down into infinity. If you don't put the arrow in, you're not indicating infinity. For another question, if we had y is greater than or equal to 3, okay, this is now a different question. So if we have our number line, and then we've got, say, 0 here, 1, 2, 3, okay, because it's also equal to 3, that's where we do the dot that's filled in, because it also includes the 3 as well as everything that is on the other side of the 3. So it's important that you don't get these mixed up. This would be for something like that, and this would be for something like that. So that's an important concept that you need to understand. Again, make sure you put the arrows on. And then one more thing I wanted to discuss with relate to this is, look at the data. If it's a word problem, if it is to determine if it is continuous or discrete. So you got to ask yourself two questions. Is it continuous? Okay, which is just a line, right, with an arrow. Or discrete, which is just dots. Sometimes an arrow as well. And the question that I wanted to bring up from one of the quizzes was, let's say gas tank has 55 liters or less. Okay, so when we look at this data, and several people did this on the quiz, and I was very impressed. They had to think to themselves. Okay, think. No negative possible, because you can't have you can't have negative gas in your tank. So what that means is when you're writing the inequality, it was something like G for gas is less than or equal to 55, and then after that you would put that G must be also greater than 0. Okay, or G cannot be a negative, something like that. And I was very impressed with the people that recognized that, because when they graphed their solution, okay, if this was, let's say this was 0 and this was 55 over here, when they graphed their solution, they said, well, it has to include 55 liters, and it has to go this way because it includes less than, but then it has to stop at 0 because it can't go negative. And that was technically the fully correct solution for that. Now, if you put an arrow over here and you included the negatives, I didn't mark it wrong. I didn't take any notes or any marks off. But really, this is the this is the full solution. And another example that was continuous or discrete data. I didn't quiz you on this, but let's just say you've got, you have to have fewer than 5 DVDs. Okay. If you had fewer than 5 DVDs, sorry, I'll separate these as separate questions. If you had fewer than 5 DVDs, there's a couple things that you need to consider, okay? So let's just use D for DVDs. D had to be less than 5, right? But, okay, D can't be negative, right? But one more thing as well, no decimals or parts of DVDs, right? You can't have half a DVD, right? Splitting it in half doesn't really work. So in this case, we would have 0, and then let's say we'd have 5, and let's see if I can space this out. 4, 3, 2, 1. Not perfect, but okay. So what are our options in this case if D is less than 5, but it doesn't include 5, so I'd have to circle that without filling it in. But it's possible that I could have 4 DVDs. It's possible I could have 3 DVDs, 2 DVDs, 1 DVD. And I guess it's even possible that I would have 0 DVDs. So that would be an example of discrete data. And the only way you know it's discrete data is by reading the question, right? And this one up here would be continuous data, because it would be possible to have 54.35 liters, right? So that's the difference between including a line and just including the dots. I'm pretty sure I did not include any discrete questions on the unit exam, so you won't worry about it too much for the unit exam. But certainly when you're doing these in grade 10 and above, they're going to expect you to look at the data, read the question carefully, and decide, is it continuous or is it discrete? So that's the second chunk that I wanted to discuss. Third chunk from the exam is the 5 steps in problem solving, right? I'm not going to go through this in too much detail because there are notes on it, there's a video on it, and there's lots of practice problems, okay? But don't skip steps. The first step, okay, is let, X or Y or whatever, okay, represent or equal whatever it is that it needs to represent, gas in the tank, or height of a plane or something like that. So you say let X equal what it needs to equal, then you make your equation if it's an equal sign, or inequality if it is going to be less than, greater than, less than or equal to, or greater than or equal to. So the second step is you just make your equation. So let's say, or your inequality. Let's make this an inequality. Let's say that X has to be greater than 3, greater than or equal to 3. Then, then you have to solve. In fact, I'll make this 5x is greater than or equal to 30. Then you solve, okay? So then you can basically just carry this on, right? So you've got your inequality here. Well, we know in order to isolate X, I got to divide by 5 on both sides, and that leaves me with X is greater than or equal to 6. So there's the solve part. And then 4 is verify. It's written backwards on one of the notes, and I don't like that. You should always verify it before you write your final sentence. So if you're going to verify it, usually substitution works, right? Okay, so if we're going to verify this, we need to pick a number that's either greater than or equal to 6. I'm going to pick 7, okay? So let's just say X equals 7. And your verification is actually 2 steps, but the first one's obvious, right? So is 7 greater than or equal to 6? Well, that's a pretty easy check right there, right? But then you've got to go back up to the original, and you've also got to plug that in. So then you've got to go, my original was 5 times X, so now it's 5 times 7. Is that greater than or equal to 30? And that's the question mark one, right? So 5 times 7 is 35. So that is indeed greater than or equal to 30. So now you've checked it. So you always have to go back up to the original inequality or equation to check it. And usually we get you to check a couple. It says 3 in the textbook. I figure if you check 2, you're pretty sure. And then 5 is your final sentence, right? So this would be, the value of X is, what did I say? Is greater than or equal to 6. And most of the time your solution is going to be in the form of a problem in real life, not just x is greater than or equal to something. It's going to say you need to have less than 55 liters of gas in your tank, or the plane is currently flying above 10,000 feet or something like that. So just make sure your sentence doesn't have to be a long sentence, just a short sentence. So most of your problems from this point forward, your word problems, are going to be out of 5 marks, right? So you're going to get 1 mark for each of these things. Don't lose silly marks for not checking or for not writing a topic sentence, especially the sentence one. I mean, really, it's an easy mark once you've done all the hard work of solving it and verifying it. So don't forget that. Negative distribution is the next thing I want to talk about. Some people are still having problems with this, even though we've been doing it since Unit 4. It's really important that you know how to do this, because it's going to come into play grade 10, 11, 12, the whole way through high school. So you need to recognize that if you've got a negative number in front of a polynomial, so let's just say it's x plus 1, and then on the other side, let's have negative 2 times 2x minus 3. If you see a constant, it's really a coefficient because it's multiplied by this whole thing, but if you see a number in front of brackets with a polynomial, you just have to remember that you have to distribute it. And I'm 42 years old, and when I'm doing these, I still put the arrows just to remind myself. Okay? So in this case, you have to multiply the whole negative 3 times x, negative 3x. Then you've got to multiply the whole negative 3 times 1, that's negative 3. Then on the other side, you got to multiply the whole negative 2 times positive 2x, that's negative 4x. And then the negative 2 times the negative 3, negative times the negative is going to be a positive, and then you solve it from there, right? So in this case, I'd have to add 4x to both sides. That cancels. That leaves me with positive x. And then, I've still got the minus 3, and I've still got the plus 6 over here. And then I'd add 3 to get the 3 to the other side. That cancels, and I'm left with x equals 9. So negative distribution is extremely important. You need to understand that concept, and you need to recognize when you need to use it. If you have, this kind of goes into the fraction section. Actually, I'll do a positive example here. So if I've got a positive 4x plus 3, okay, is, let's just say less than or equal to 2x plus 1. Okay, if you've got positive numbers, you still need to distribute. You're just not distributing by a negative number. Okay, so you still need to take it down to 8, 2 times 4x, 8x plus 6 is less than or equal to 6x plus 3, and then solve the equation, keep going down. You know how to solve the equations. I just want to make sure that you're distributing. So that's another example. You always have to distribute if you see something like this. Just be careful if it's a negative number, because the negative number has to be multiplied for each of them. The other one that people struggle with is something like this. Okay. And okay, this is the same thing as having a negative 1 there. And if it doesn't matter that there was no coefficient there, when you just see a negative, you assume that the coefficient is 1. You just don't write it. All the negative does in front of the polynomial is it flips the signs. And some people I noticed were putting this on top of their signs inside the brackets. That's perfect. That's fine. So now you know that whatever was here is a negative x, and whatever here is a negative 2, and then over here it's a negative 3x, and over here it's a negative 2. The only thing you want to be careful with, and I noticed some people did this too, is if you do this step here, okay, you're basically getting rid of this. So if you do this step, get rid of that negative sign, because you don't want to be multiplying a negative by a negative. You just undid all the work you did. So, sorry, this should be negative minus 2. So if you do this step, that's perfectly fine, but make sure that you cross out that negative, or more accurately, just replace it with a positive. So basically you're changing this sign and then the signs of everything inside the brackets. That's only if you've got a negative sign. If you've got a negative coefficient, like up here where we had negative 3, make sure that you do the whole negative 3 times x. You can't just flip the signs, you also got to multiply too. So that's your negative distribution. Okay, another thing that's still troubling some people is killing fractions. Okay, killing fractions. Okay, do it first. Okay, and then find the LCD, which is the LCM of denominator. By this point, I shouldn't have to explain this, but when you got a fraction, the denominator is the one on the bottom, right? So let's just put in a question like we've got 2 over 5x minus 3 over 5, and then let's just say that equals 1 over 2x plus 3 over 10. So we've got fractions all over the place, but they don't need to be scary. Okay, so we've got to find over here, the first thing you got to do is you got to find the least common multiple. Okay, just in case you forget what the LCM is. So the least common multiple of 5, because that's one of your denominators, 2, and 10. So what's the lowest number that we can use out of these that they all divide or multiply evenly into? And that's going to be 10. So what you can do, or what you should do at this point, is you need to multiply everything, every term, by 10. So it looks like this: 10 times the 2 over 5x minus the 10 times the 3 over the 5 equals the 10 times the 1 over 2, or the 1/2 x, plus the 10 times the 3 over 10. And some people were just doing it to, let's say there was only one fraction in the whole equation. They were just doing it to the one fraction. You can't do that. Once you multiply a fraction by 10, you got to multiply everything on both sides by 10. And then what you do is simplify, okay, which is really reducing tops, which are numerator, and bottoms. So I'll just do it up here. So I cross out the 10 and I cross out the 5. What's 10 divided by 5? It's 2. I cross out the 10, I cross out the 5, and that's the same thing. 10 divided by 5 is 2. Over here, I cross out the 10, I cross out the 2. What's 10 divided by 2? It's 5. And then over here, I cross out the 10, I cross out the 10. What's 10 divided by 10? It's just 1. So, you could write it up there, but you don't have to. Then you have to multiply by what's left, right? So then you always got to multiply. Don't forget this last step here, right? So I've got 2 times the 2x left, so that's 4x. Then I've got negative 2 times 3 is negative 6. Then I've got 5 times 1x is 5x. And then over here I've got 1 times 3, positive, which is just 3. And then from there, you can solve it further, right? So we've got, we've got to do minus 5x minus 5x. It's going to be negative x minus 6 is equal to, that's canceled. Then I've got to add 6 to both sides to get the 6 on the other side. That cancels, and that's going to be 9. And then I've got to change this to a positive x, so I've got to change that to a positive 9. But the important part here is you can't get to this easy part, because this is the easy part down here. You can't get to that part unless you understand how to kill the fractions. And we don't want the fractions there. We got to get rid of them. So that's very important, not just for this class, but for every other math class. I had some students say that, I had a student say that they are in the habit of taking fractions and making them decimals right away. And, it's good that you know that you can do that to get to the proper, sort of real life answer. But the reality is you need to learn how to work with fractions. If you are converting everything to a decimal, you're really going to struggle in grade 10, 11, and 12. So you need to be able to work with fractions. And our rule has always been, if you start with fractions in your question, you have to end with either whole numbers or fractions. You can't be throwing decimals in there. So one more thing I want to address with regard to killing fractions, and it's something like this. And it doesn't matter if it's an inequality. It doesn't matter if it's an inequality or if it's an equality. What if we've got like a fraction outside? Okay. What if we got a fraction? Let's do this as a negative outside of a polynomial. Okay. This is where I disagree with some math teachers. Some math teachers say you should apply this, distribute it, and then kill the fraction. I hate that. Okay? But what you need to remember, if you're doing it the way that I want you to do it, is you only have to worry about this and this because these are multiplied. Okay? There's no plus or minus sign between the half and the polynomial. Okay? There's no plus or minus sign. So what that means is, remember, 2 times 3, okay, is the exact same thing as 3 times 2. So it doesn't really matter as long as it's multiplication. I don't want to actually confuse the point too much. But the point on this one is only kill the fractions out front in this situation. Okay? Don't put it on everything inside the brackets. You won't run into these all that often in grade 9, but you will run into them very often in grade 10 and above. So here we need to decide the LCM, right? So the LCM, the least common multiple, is 4, right? Because we only got a 2 and a 4, and LCM is going to be 4. So what I need to do is I need to multiply the 4 by the half, and then the half is already multiplied by the negative 3. Then that's less than or equal to the 4 times the negative 3 over 4, and not the stuff in the brackets, because there's still multiplication there. It's not separated by a plus or a minus. And then we just do the same thing we did before, right? We cross out the 4, cross out the 2. 4 divided by 2 is 2. And then on the other side, we've got a 4 up top and a 4 on bottom, which just leaves us with the negative 3. And then we distribute. So now we distribute 1 times x is x, 1 times negative 3 is negative 3. Then over here, we've got negative 3 times x, negative 3x, and we've got negative 3 times a positive 2 is negative 6. And then, after we get to this point, this is the easy stuff, right? We killed the fractions, and now this is the easy stuff. So we've just got to get rid of the negative 3, so let's add 3 to each side. So that cancels, and that leaves us with x is less than or equal to negative 3x. And then this is minus 6 plus a 3 is going to be minus 3, or negative 3. Now I got to add 3x to both sides. You know how to do this. We've been doing this for a long time. So this is 4x, this cancels, and this is negative 3. And now, where we're at the very last step, we need to make the x, but we had to get the x by itself. So we need to divide both sides by 4. Okay, now this is going to cancel. We do not flip the sign because we're only dividing by a positive number. And then over here, we are left with negative 3 over 4. So we started with fractions and we end with fractions, but we wanted to kill the fractions up top to make it easier for us to get from, this part to the end where we had another fraction. So if you need practice killing fractions, there's lots of text examples. There's examples in the practice questions in the video, and the videos for 6.5, and there might even be some in 6.3. And there's lots in the textbook as well. So make sure you're familiar with that. Very last thing, and I already sort of did it, verifying equalities and inequality. No, sorry, not equalities. Equalities would just be equations. Verifying inequalities is what I meant to say. Okay, just use substitution. It's really easy. Okay, so use substitution. And usually 2 numbers if I ask you. Okay. So if we've got, let's just do a question where we've got 3x is 3x minus 5 is less than or equal to negative 2x plus 10. So we're going to solve the inequation, right? So I got to add 2x to both sides, and then we're going to have 5x minus 5 is less than or equal to 10. Okay, so we've got 5x. We've got to add 5 to both sides to get the 5 to the other side. So we've got 5x is less than or equal to 15, and then we've got to divide by 5, and we're left with x is greater or less than or equal to 3. So we've solved the polynomial, but now we got to check. So here's our check or verification. Okay, let's do it with 2 numbers. Okay, the first check is super easy. All right, the first check is let's just do x equals, we got to pick something that's less than or equal to 3. So let's pick x equals 3. Okay, so the first check is actually super simple, right? Because you just sub in 3 for x, and we've got 3 is less than or equal to 3. Well, that's obviously an easy check, right? And then over here, we've got to plug it into the original equation. So it's going to be 3x, so 3 times 3, minus 5. Is that less than or equal to negative 2 times 3 plus 10? Okay, so that was our original equation. And then we find that this is 9 minus 5 is less than or equal to negative 6 plus 10. 9 minus 5 is 4. Okay, and negative 6 plus 10 is also 4, so that checks out. So that would be checking with one number, and then your second number, let's check with something that's less than 3 again. Let's check with 0. Okay, you can pick whatever numbers you want as long as they are true over here. So if we check with x equals 0, the one side's obviously very easy. Is 0 less than or equal to 3? That's an easy check. And then on the other side, we've got 3 times x, which is 3 times 0, minus 5. Is that, and I should put a question mark there, is that less than or equal to negative 2 times 0 plus 10? And so 3 times 0 is 0, so that's minus 5 over here. Is minus 5 less than or equal to? Well, that's 0 there, so it's positive 10. So that's an easy check. So you can pick which numbers you want to verify with. Usually, in the exam, I'm going to tell you which numbers to check with, just because I don't want you accidentally picking something that wouldn't fit in here. Like say if you accidentally picked 4, you wouldn't get an equals, and I didn't want anybody to be confused by that. So I'm going to tell you exactly what to check by. But make sure you are able to use that substitution method. And again, this is easier than substituting to check with equations, because you know one side's already going to work out because you picked a number that was going to work out. So those are the things that I noticed on the quizzes. And most people did really well on both quizzes, and I think you're ready to write the exam. If you've got any questions about these, please let me know, and I will get back to you as soon as possible. Best of luck on the exam.